Okay, so going back to the row operations, okay, like dealing with operations among columns and rows. And let's say that if we're looking at the determinants of a 4 by 4 matrix, and this one is pretty strenuous to say the least. Okay, and we'll say we have A to consist of these elements. For the top row, we have 0, 2, negative 4, 5, 3, 0, negative 3, 6, as well as 2, 4, 5, and 7. And the last row, we have 5, negative 1, negative 3, and 1. And you can sort of think along the lines of like the Gauss-Jordan elimination, or even, or more succinctly, the reduced row echelon form. And what I can do here, like going back to our properties again, so if I'm looking at the determinants of this matrix, and let's say that if I want 3 from the second row, or the second row to be on top, I can interchange the first 2 rows. And if I interchange, anytime I interchange, any interchange activity means I'm going to have to apply a negative sign or take the opposite sign. So each interchange, like if I go from starting out with a positive determinant and I interchange rows, I'm going to go to a negative. And if I interchange again, I'm going to go back to a positive. And so if I interchange, now I'm going to have 3, 0, negative 3, and 6 at the top, 0, 2, 4, 5 on the bottom. And here, if you notice, you have 3, 0, negative 3, and 6. Now, before I gave examples with 3 by 3 determinants where I had like 3, 6, and 9 at the top, and I could have factored out 3, but I did not, but I could have. But in this particular case, now I got 3, 0, negative 3, and 6. All these values are multiples of 3. So what I can do here is I can change the 3 in the upper left-hand corner to 1. If I factor out 3 from the first row, notice I have the negative sign developed from the row interchange, where I had switched out row 1 for row 2 and vice versa, and factoring out 3. So we'll have the coefficients at the front at negative 3, and the top row becomes 1, 0, negative 1, and 2. And getting closer to like a Gauss-Jordan elimination format, okay, what I'm going to do here is I can make the leading 2 from the third row into a 0, and the leading 5 from the last row into a 0. If I subtract 2 times the first row from the third row, and also subtract 5 times the first row from the last row. And so while the first 2 rows, okay, remain stable, we have with the third row, we have the changeover to 0, 4, 7, and 3. And again, we have the last row got 5 minus 5 is 0. Negative 1 minus 0 is still negative 1. And negative 3 and what's going to be plus 5 becomes 2. And 1 minus 5 times 2 is going to be 1 minus 10, which will be negative 9. So here I had the first column with 1 and only zeros underneath. And what I can do here is now, notice, okay, for another interchange, okay, I can interchange row 2 and row 4, and with the interchange we have another application of a negative sign. So in this particular case, all right, so we have second row have 0, negative 1, 2, negative 9, and now the last row I have 0, 2, negative 4, and 5. Notice I have a negative of negative 3, so this will be a positive 3. So I'm going to be using this determinant layout leading up to the next steps. Okay, so what I'm going to do here, I'm going to factor out negative 1 from the second row. And if I do this, I'm back to negative 3. So here, the second row now becomes 0, 1, negative 2, and 9. Okay, and looking at the signs of the cofactors, again, you have alternating, again, we have plus, minus for a 4 by 4 matrix in reference to the top row, and looking at changing up the elements. So now going from this stage to what I have immediately. Okay, so we're looking at subtracting 4 times the second row from the third row. Okay, so I got like 0 minus 0 is 0, 4 minus 4 times 1 is 4 minus 4, which is 0, 7, and what's going to be plus 8 becomes 15, and 3 minus 36 becomes negative 33. Okay, so notice I have a diagonal array, so I got 1 and 1, and I can make the 15 into a 1, and I can factor out 15 ultimately, but we'll get to that. And right now, say that in terms of if I were to go with column arrangements. Okay, so if I add 2 times the second column to the third column. Okay, so I have like -1 plus 2 times 0 is -1. -2 plus 2 is 0. 15 plus 2 times 0 is still 15. 0 plus 0 is still at 0. And again, just referencing, factoring out 15 from row 3. If I factor out 15, the outside coefficient, we're going to have -3 times 15 is -45. And the third row, I'm changing from 0, 0, 15 and -33 to 0, 0, 1 and -2.2. And notice, okay, I have these zeros in the triangular pattern, and I can make this -13 into a 1. Okay, so continuing, if I were to factor out -13 from row 4, okay, notice your coefficient -45 times -13, that will become 585. And the last row we have 0, 0, 0, and 1. And with the signs of the cofactors, okay, in terms of a 4 by 4, we have plus, minus at the top. And I can just, I could sort of take out the determinants, but I'm just going to do this one more time. We're going to make this -1 at the top into a 0. So I'm going to add row 3 to row 1. So I got like 1 plus 0 is 1, 0 plus 0 is 0, -1 plus 1 is going to be 0, 2 plus -2.2 becomes a -0.2. And for what we have in the case of the setup here, okay, I can go ahead and take the determinants. Okay, so we have, so you got 585 on the outside, and you got times, okay, you got +1, and again, with the, from this, okay, we have the first row, first column, okay, minor, you have 1, 0, 0, 0, 1, -2.2, 0, 0, 1, and for what I have here now, it got -0 plus 0, so those are just going to be negligible. Now I got, for the last, I got -0.2, and looking at the first row, fourth column, minor. Okay, so I'm going to have 0, 1, 0, 0, 0, 1, 0, 0, 0, and if you notice, we have last row is going to consist solely of zeros, and this is one of our zero determinant properties. Okay, if you have either an entire row or an entire column, in this case we have both, first column, last row, you have with zeros, and so that is going to be negligible. And so what is left over, you have 585 times 1. Okay, and so you got 585 times 1 is 585, and you got the, like the +1. Okay, so looking at this particular part here, and you have times from this, the first row, first column, minor, so you have 1, -2.2, 0, and 1. So you got 585, and 1 times 1 is 1, and 0 times -2.2 is 0, so you got 585 times 1 times 1, and the final result ends up at 585.